Good morning, everybody, and welcome to the next DATRON Digital Experience event. My name is Fabian Put. I'm product owner for CNC Systems, and this is my colleague Mark Reis.
Good morning, everyone.
Today, it's all about clamping systems and clamping devices. Mark, before we get started, I would like to let you know that after this session, the two of us will be available in the chat. You find it on the right side. And you can, ask us any questions you want. Feel free to use this to get more information to our products. First of all, our big USP in DATRON clamping systems, the vacuum table. Mark, can you tell us something about this?
Absolutely. What we can see here right behind us is our ML Cube machine, and we have equipped it with different types of clamping. As Fabian just mentioned, we have a vacuum table right here in the center. We have some mechanical and pneumatic elements, also some special clamping devices where we made a jig, and we're gonna talk about every single one in detail during this session. You just said the vacuum technology, vacuum work holding is the most common one on DATRON machines. That is absolutely right. The majority of our customers out there in the field proceed with plate materials and machine like sheet metals or like 10, 15, 20 millimeter aluminum plates. And for this, the vacuum table is the perfect solution because it lies flat on the table. We hold it down just by the under pressure, the vacuum that comes from below, so we can machine parts completely. Let's take a quick look at the technology in detail. So the vacuum pump, which creates the vacuum, sits behind the machine, and the airstream, the airflow goes through these connectors right into the table. So we have, on this machine, we have 6 of these connectors, so the airstream goes through it into that sandwich plate. And in this sandwich plate, we have those fields that have 100 by 100 millimeter, and we can like open and close, so activate and deactivate them just by turning this little rubber plug. And the key behind this is that we can focus the vacuum just to our part size. So if this is our stock material, which is more or less 100 by 200, we're opening up these sections, these two, so the full vacuum force will come into this area. Now before we clamp the part, I'm putting a sacrificial layer in between. So we have this kind of cardboard that goes between the vacuum plate and the actual material. And it has 2 functions. The first function is it distributes the vacuum equally through the plate and holds it back when we have breakouts, when we have holes that go through the parts. And the second function is, what I just mentioned, is we can cut entirely through the material. So we can go a little deeper than the actual material size is into that cardboard. At the end, we can just throw the cardboard away, the vacuum card away, use a new one for the next part, but the part will be super clean. We have clean edges. And once I switch the vacuum pump on and my vacuum is now in this area, I am not able to move this part. It's super strong work holding. And now we can use our high-speed machine and high RPM machine to machine any contour, machine any part out of this.
Now to see this in action with real milling, we prepared a video for you.
Yeah, and what we can see here is at the beginning pretty much the same as we did on the machine, but the question that comes up and also came up during our in preparation over social media was, what's the smallest size that we can hold on vacuum machine beds? And the answer is more or less always the same. It kind of depends, because the quality of the surface is very important. So we need a flat, super flat surface, and not a kind of a rough from a bandsaw or something like this. But what you can see in this video is we have quite small parts on the vacuum card with an additional glue layer on it. It's the vacuum card double plus or triple plus. So we combine the vacuum force, so over the entire surface, plus a layer of glue, like an adhesive layer. So we can combine these kind of pneumatic or airflow work holding plus some sort of mechanical, and what you just saw is that those parts are really tiny.
That was actually one of the questions before this event we got via social media. That was one question. How is it possible with really small parts? That was the answer. You can get these vacuum cards with glue on it, and you are able to mill small parts even on vacuum.
Yeah, and the second key to hold very tiny parts on the machine bed is to use like very small tools to cut through, because the less cutting force in X and Y direction, the more stable it will hold on the machine bed.
What also helps is if you have parts with a really flat surface. Yeah. I didn't know if you mentioned this before, but it also helps always when you have.
Sure, if you have like workbench in it,
great surface.
It's mandatory to have a good piece of raw material.
Yes. Okay, thank you, Mark. We've seen this vacuum system on a ML Cube here. This means 1000 by 1500 millimeters machine table. We have it. So we have, in this case, only one vacuum table. So this is 500 by 1000, and you are able to use up to 3 of these plates. In this case, we try to give you a little bit more variety of different clamping systems. This is why we have used only one vacuum plate. And so now, can you tell us how are these clamping devices mounted on the machine? Is there any special trick for this?
Yeah, so in fact, all of our standard vacuum work holding solutions, plates, no matter if it's vacuum or anything else, they have the conical principle. That's what I would call it. So when you look at the table, we have the polymer concrete table in black, and you see these silver inserts. These are steel inserts with a thread in it and a conical shape right here. Now the secret is, once a machine is assembled and calibrated, at the very last step before it like leaves our production line, it will mill these cones by itself into the table, which means we have like a perfect alignment from like the entire gantry, the entire machine to the table. And the work holding plates have these counterparts here with a through hole. So what I can just do is I place this on the table. You use screws like M6 regular cylindrical screws, and you bolt it down to the table. Big benefit of this is I don't have to align anything, like especially when we look at like mechanical devices or devices in general, where you want to make sure that they are parallel to your machine system. You don't have to do this. It's like always on the same spot.
So it's kind of a zero clamping systems.
Pardon me. Yeah, absolutely.
Okay. So information for you. All our DATRON clamping devices are equipped with these conical parts.
Yeah, and
so all the devices over here.
And even if you have the need for any like customized design, you can get those cones as single pieces, so you can just equip your own with them.
Okay, this for now. We have prepared a survey for you. What we are interested in is what are the main clamping devices you use on your DATRON machine. Please start the survey now. We will come back later to this.
It'll be interesting to know.
Okay, Mark. What other clamping devices do we have here?
All right. On the right-hand side of the table, we have a standard centric vise. So this is pretty much self-explaining. We have the base plate, which is in steel, and we have soft jaws sitting on it. You get these in 2 lengths, so that's the short version. Another one is around 100 millimeter longer, and you also get these soft jaws in a wider dimension, so you can cut any geometry in just like you want. We have straight edges here now, but it could be also like curved or anything else.
Okay, so on the right side we have a Tslot plate. What can we
Yes.
do with this one?
The Tslot plate has a couple of functions. So in this case, I have mounted two of these, what we call short stroke elements. Those have two cylinders built in. One is vertical, you can see it's underneath here, and one is horizontal. So with these bolts, I can trigger these pneumatic elements. So I can release this T-stone down here. So I can move the element over the table. Once I take my finger off, it's super stiff and firmly held on it. And with the upper one, I can release a short stroke in the horizontal direction. So it will push it against the fixed jaw. Let me just quickly get this.
So
Party.
one button is for moving and one button is for the actual clamping.
Right.
Okay.
So I'm putting this in place. Oh, let me just get my soles a little bit tight. So I put it in place first, or both, and now it's already like in position, and all I do is I put pressure in the Y direction, and now it's firmly held on the machine. I mean, this technology is extremely flexible, and a lot of our customers use it for various applications. Nevertheless, it has limits. So if you have like a high amount of roughing operations, when you work with kind of big tools like 16, 20 millimeter tools, and there's a big cutting torque and force, it's still pneumatic, it's still air. So it can reach its limit there, but if you have like smaller, more delicate parts, you can also decrease the air pressure.
Okay.
So if you have, just imagine a little kind of credit card plastic that you want to clamp because you need to engrave something, you just take the pressure down and just make sure it's not like bending completely upward. So that's extremely flexible.
Okay. So if you don't want to use this mechanical vise, and for example you have a Tslot plate on your whole machine table, we have another opportunity for you.
Yep.
You can use this. You can also use this T-slot for other mechanical clamping devices. We have two of them over there. Mark, first of all, you get rid of these.
Yeah, let me quickly
pneumatic clamp.
Let me quickly remove
Pneumatic
those.
clamps.
And
Maybe
then
we can
let's
show them over here first.
talk about these wedge clamps, right? So, wedge clamp, hope we can see this. It has a T-stone down here. This side will be fixed on the T-slot table, and with this angled part here, we give pressure downwards and a little bit onto the fixed jaw. So let me quickly demonstrate this. So I'm having a standard aluminum extrusion profile that I want to hold. So I just bring them in place. Thanks. And then tighten them down. So now, because of this angle, the clamping force goes to the bottom and to the fixed jaw, which holds the part down then.
These also seem very flexible.
Yeah.
I think we have them in different kinds. We also have fixed ones over here, and we also have
this kind of this is a double clamp, so it goes in both directions.
Oh, this is the double clamp, and
yeah.
we also have fixed jaws for this case.
Right. We have a short video that demonstrates the purpose and the application quite well. So pretty much the same setup as we've seen right now, but we're also using it as fixed jaws on the back. Holding it down. So you can actually use these as like a multiple setup. Like now in front, you could still use another extrusion profile to hold and just make them or put them in a row, set them up in a row.
Okay, that looks really nice. Okay, now maybe we have the opportunity to look on the results of the survey we gave you.
Oh yeah, that would be interesting to see what our viewers say. Oh, that's quite equal.
Oh, I didn't think
so, yeah,
it will be.
So it's very equal between mechanical work holding, pneumatic work holding, and vacuum. So I would say that's everything we've presented is representative.
That's nice, but also maybe you got the you found something else. You found something that fits better for your application in this video. Feel free to try something out.
Yeah.
Okay. I think we are quite done with this machine.
For now, we're going to look at the special fixture later on, but I think you brought a nice part here.
Yes. Good question, Mark. So, what if the part is too high to actually mill some surface?
Yeah, let me quickly have this and show it to the camera. So this is a part which looks perfect to make it on a vacuum or on like mechanical work holding, but we have these 3 threads like on the top sides, actually on both.
We can show it
maybe
from
you
a
can
closer
also
look.
From here. So there are 3 threads on each side. So this part, no discussion, it's way too high to put it in the machine or to hold it just by a centric vise. So let's quickly go over to the M8 Cube right beside us, because we have the vertical clamping system there, right?
Okay, before we start with the vertical clamping system, let me introduce you to the M8 Cube. We have a special thing over here. All DATRON machines are available with 2 kinds of tables. On the one hand, we have the full-size table, and in this case, we have the table with a cutout. This means all tables have a cutout over here in the front, and you can use this one for several clamping devices. For example, you can use a rotary table or something else.
Yep.
And you also are able to use a vertical clamping device, which one we want to show you now.
Exactly. So we have this Tslot plate mounted like on the front side of this cutout, Fabian just mentioned. Down here we have one beam that is able to give us the stability like on the bottom to set our bottom stop for different parts. We have some pneumatic connectors here, and on the top we have this beam that holds 3 of these, if you can get it a little closer, of these pneumatic clamps here. Hope we can see this. Yeah, that's a nice view. So this is where the clamping force comes on. Now if I have a part like this, I can just place this down there, move that beam a little over, let's take another one, it'll lock in place, and then I put the clamping force on, and now the part is firmly held here. So this is just like the standard equipment and the standard solution, but just as before, on a Tslot plate, you are extremely flexible. I've seen complete centric vices mounted vertically here, so yeah, full flexibility.
It's also possible to use the wedge clamps in this T-slot.
Yeah, true.
So you are even more flexible in this case.
True.
Okay, that's it pretty much to the vertical clamping device. Now I've seen one of our smartest clamping device already.
Yes.
Maybe we
quickly
can
get the part
remove
here
this
out.
one. Yeah.
All right.
I think This one is a pretty good example for this clamping device we want to talk now.
Right.
The DATRON Axis 4. What's this? Can you tell us something about the Axis 4?
It's a rotary axis, and it's a great accessory to the machines because it opens up so much possibilities, so much options for a different approach when it comes to making parts. So if we can get a close up to this part.
Sure.
So this is like a prototype of an endoscopy housing, and what you can see is we have different angles and features right here. So what we did with this part is we held it in a centric vise, had one setup, and then just putting it into different angles, making all the features, and at the end, this is a bit too thick now, but usually you would do a thin tap here so you can just break it off.
So you can almost finish the parts already in the fourth axis.
And it is something that is getting more and more common, that parts that are more where you would actually see it's a 3-axis part, but you would have to flip it a couple of times, making it on the 4th axis because it just saves so much setup time. It's kind of a different approach, but it's sometimes definitely worth it.
Okay, so some words to the Axis 4. It's actually optional, and it's available for all DATRON Next machines. This means, of course, the DATRON Neo at the first place, but then all M8 cubes, ML cubes, M10 Pro even, and of course MX cube with DATRON Next control. You can get this one. Ask us if you don't have the preparation for it. Maybe we can use something in this case, but it's optional, and it's a very nice clamping device for more variety.
Super versatile, and I love working with it.
Okay, so before we come to the end, I think we prepared some special clamping devices, customized clamping devices.
Exactly. So
what do we want to start with?
Special clamping is always important when you have like irregular geometries, irregular contours. And as a first example, we've brought this aluminum guitar. So what you can see, it's a guitar body, and it doesn't have a lot of straight edges. Now, milling this from a solid block means it looks like this after the first operation.
So this was one. This one was on vacuum, right?
That's on vacuum, right? So that's just plate material, and you can rough all the cavity out like this. Can be seen better. But how to flip it over and remove like the rest of the material from here to there? And therefore, we've made a special vacuum jig that we want to show now in the machine. It's an aluminum plate with a polyurethane block on top, and we've made this jig, so the negative form of the inside of the guitar. The vacuum goes like into this PU and is distributed in these 10 little chambers with a like a sealing gasket, like a rubber band inside of it. So all you can do now is there's like a little bit of play, so it sits nicely. And let me just quickly switch to the vacuum section. Now, if you switch the vacuum on, it holds super tight. So we have extremely high work holding force here. And on this application, we've been using 24 millimeter tools for like a pretty high performance roughing. So we need to make sure that the parts are firmly held.
So this is really important, so you don't get any crashes. So what else do we have? I think we have this little frame over here.
Yeah, pretty much just kind of the same challenge, I would say. It looks a little bit easier than this big block, this big guitar block. But if we can get a close up here, there is a little step right here of 0.3 millimeters.
It's pretty tiny.
That's not a lot, but that's what the model says. So we need to make sure that we equalize this little step, and we've made this Yeah, pretty much the same way. This jig, just we made it out of aluminum. You can see it in this camera quite well. So we have 4 sections that, let me hold it and you put the camera on. 4 sections, sorry, that hold it on the part, and a 5th one that holds the rest material in this window. So that gives also a great stability for this upper side operation.
Okay, so kind of the same thing.
Yeah.
We always we have always the opportunity to create some customized clamping devices, which actually works pretty well with vacuum, right?
Yeah, yeah. It's, I mean, if you make soft jaws on a centric vise or a pneumatic clamp, I mean that's very standard. On the vacuum, it's kind of a bit more challenging, making sure that the sealing fits in, that your area of contact of the vacuum is still high enough, but it's definitely worth it, even if it comes to serial production. Okay, thank you for this. I think we have one more last piece, which came from our colleagues from the Netherlands. I think we got some pictures. Yeah, thank you for sending this in. So this was an actual project as well. It's a smartphone case for like heavy duty purposes. So it's made out of aluminum, and in the next picture we can see this really great setup of an M8 Cube. So we have half of the table equipped with a vacuum plate, 700 by 500. We have the axis 4 as a rotary axis, a centric or mechanical visor in the back, and a 3-jaw chuck somewhere in between. So pretty good utilization of the machine table. And in the next picture, we see the nesting on the vacuum, great technology. So we do, or they made 6 parts in one shot on the vacuum, and used the 4th axis for the like top and side milling, the little breakouts and pockets that were in. So that's, yeah, like the perfect example, I would say, for how to utilize such a machine table with various work holding solutions. Thanks a lot to the Netherlands for these impressive pictures and videos. Yep, it's always great to see something like this. All right, so I think we come to the end now, but before we close the session, I would like to talk to you again to the chat. Yeah, if you have questions, feel free to ask us. We'll be there like a minute after the session has closed. I think we will be available for the next 15 minutes or so. Absolutely. Ask us anything you want, feel free. And now, thank you, Mark. Thank you very much for your time, and thank you for visiting this live session. Thank you. Thank you so much. Stay safe. Bye. Goodbye.